to solving quadratics, and it's solve by square roots. There are several methods that we're going to do on solving quadratics. The method that we choose just depends on the type of problem it is, the numbers and stuff. I will pretty much always tell you what method to use. So this first one is using the square root method. So when you solve a quadratic, essentially you are finding the x-intercepts. So we've looked at standard form and vertex form. You found the vertex, you found the axis of symmetry, you found the y-intercepts, possibly, the max, the min. But one thing you have not found from an equation are the x-intercepts. And we're going to spend like pretty much the rest of this unit finding x-intercepts. A quadratic could have a 0, could have 1, or it could have 2 x-intercepts, also known as solutions, also known as roots or zeros. In order to solve with square roots, we have to practice working with square roots. We have to practice simplifying square roots that don't give us whole numbers in the calculator. So to start, I want you on your own to use your brain or your calculator to fill out these numbers. 1 squared means 1 times 1. 2 squared is 2 times 2. So go through that. Alright, so I'm going to go through these really quick. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Those are the first 12 perfect squares. You could keep going forever. There's an infinite number of perfect squares. But what it means is when you take the square root of any of those numbers, you get a whole number. What's the square root of 9? 81. Square root.
What do you mean, like it's 9 times 9, right?
No, what? You're going backwards. 3. When I say what's the square root of 9, it's 3. What's the square root of 25? 5. What's the square root of 144? What's the square root of 64? 8. If I say what is 9 squared, that's when you say 81. They're opposites of each other. So a perfect square is one that when you take the square root, you get a whole number. Notice if I say what's the square root of 20, it's somewhere between 4 and 5. It's because 20 is somewhere between 16 and 25. If you do the square root of 20, it's 4.47. So it's somewhere between 4 and 5, but it's not a whole number. So 20 is not a perfect square. We're going to be working with numbers that are not perfect squares. And I'm not going to allow you to give me a decimal. I don't want you typing them in. We're going to simplify them so that there will still be a square root as part of your answer. So that's what we're going to start with today. So number 1, I have the square root of 4 over 9. Now if you type this one in your calculator, it's not going to give you a decimal. It is going to give you a fraction. But I just want to point out something here.
How do you do a square root?
In the calculator, you hit the second button, and then you see above the x squared button, down about halfway on the left, it has a square root symbol.
Oh, yeah.
Yeah. You can, that's really the easiest way, honestly. Second, and then the x squared button. All right, so if you have a fraction, and you're taking the square root of a fraction, that is the same thing as having the square root of 4 over the square root of 9. If both the 4 and the 9, the whole fraction is under the square root, you can split it up. And what is the square root of 4? 2. What's the square root of 9? 3. So the square root of 4/9 is 2/3.
Let me guess, it's not the simplest one.
Nope, that is.
Oh, good.
Yep. Try number 2.
We just put it in our calculator and said do more.
Well, it would have given you 2/3, but I still want you to write this step out. We are going to get to some where your calculator would not give you the answer that I'm looking for.
Teachers, pardon this interruption. If you could, please check your email. We do have.
You should have written number 2 as the square root of 1 over the square root of 81. What is the square root of 1? What is the square root of 81? Yep. So 1 over 9. Number 3. When you have a number out front, you do not treat it like the distributive property. We're not going to do 2 times 144. This is 2 times the square root of 144.
Okay, how do we know when we have to multiply or divide?
Well, if it's a number right in front of it, it's multiply. Kind of like when you have 2 times 2 and an x, that's 2 times x. What is the square root of 144? 12. So this is really 2 times 12, which is what? 24.
You about got us off.
Those are the easy problems. Now we get into the square root of 32. Type that in your calculator. Yeah. And I will not accept that decimal as an answer.
Okay.
So the square root, we're looking to simplify it, which means we're going to rewrite it. It's in an answer that's going to be equivalent, like it's the same answer, but it's more simplified. Like instead of saying 5/10, 5 over 10, what would you normally say instead of 5 over 10? 1/2. 5/10 is the same as 1/2. So what we're doing is finding some things that we're looking at some smaller numbers, but they're still equivalent. And here's what we do. We're going to rewrite 32 as 2 numbers being multiplied.
3 times 2?
4 times 8.
Okay, so 3 times 2 is not 32. 4 times 8 is 32, but here's where you have to be specific. Find to be perfect square, but typically it has to be the biggest perfect square. So some numbers like 32, there are multiple perfect squares that go into 32 evenly. I need the biggest one. The simplest way, probably not the quickest way, but the simplest way to figure this out is start with 32 and then divide it by your perfect squares. And we're looking for the perfect squares that go evenly. Because I want the biggest one, I'm going to start with bigger numbers and work my way back. Now, if I'm dividing, I'm definitely not going to divide by numbers bigger than 32. That for sure would not give me a whole number. So I'm going to start with 25. I'm going to do 32 divided by 25. Did that go evenly? No. Then I'm going to go to my next one. 32 divided by 16. Did that go evenly?
Yeah.
Yes, it did. So I'm going to rewrite this as the square root of 16 times 2. So, Dwayne, you said 4 times 8.
Yeah.
4 is a perfect square. If you chose that, your answer would not be completely simplified. It would be like you still are giving me 2 over 4 instead of 1/2. I want it completely simplified. So you've got to go with the biggest perfect square. Then, just like I did with the fraction, I can split these up. This is the same as the square root of 16 times the square root of 2. Because I chose a perfect square, I can now say, turn this into a whole number. What is the square root of 16?
4.
4. The other one, you just bring it down beside of it. So my final answer is 4 square root of 2. Let me tell you a common mistake that I see. A lot of people do this one, and then they say, 4, the square root of 4 is 2. They want to take the square root again. Once you have taken the square root once, you don't take it again. You just take it one time. Once you do the square root symbol is gone. Your answer is 4 square root of 2. If you want to check yourself, you can type in the square root of 32. And you can type in, 4 square root of 2. If those decimals match, then you're probably correct. And I say probably because you would get the same decimal even if it wasn't completely simplified. So if you pick 4 and 8, you get the same decimal. But at least you know you're kind of on track. If you get something way off, then you definitely messed up. All right, so let's go to number 5.
On your calculator, or you go up real quick? I don't feel too different person.
All right, let's go to square root of 12. I'm going to rewrite that. Now, you're not going to say, 6 times 2, because neither 6 nor 2 is a perfect square. We're going to take 12 divided by these numbers right here. Don't pick a number bigger than 12. Start with 9 and work your way back. Okay, 12 divided, I'm going to pretend like you don't have no idea. 12 divided by 9, not a whole number. 12 divided by 4 is. So I'm going to rewrite this as 4 times 3. Because 4 times 3 is 12. And then I can split it up. The square root of 4 times the square root of 3. And what is the square root of 4? 2. 2 square root of 3. You shouldn't have to be typing in square root in your calculator because you've got all these numbers up here. Let's look at number 6. We've got 112. Okay. So 121 is bigger than 112. So I'm going to start with 100 and work my way back. 112 divided by 100, not a whole number. 112 divided by 81, not a whole number. 64, not a whole number. Keep working your way back. If you've already found it, that's fine. I'm going to work one by one. 112 divided by 49, nope. 112 divided by 36, nope. 112 divided by 25, still not a whole number. 112 divided by 16, there it is. I can rewrite 112 as 16 times 7. Because 16 times 7 is 112. And then I can make this the square root of 16 times the square root of 7. And what is the square root of 16? 4. And And then the other one is square root of 7. So the one that is a perfect square is the one that comes out and becomes a whole number. The one that was not a perfect square just stays as is. I'm going to give you a little bit of time to try number 7 on your own. $245. What perfect square did you all find that went into 245? 49. This is 49 times what? 5. So you should have done 245 divided by 144. 245 divided by 121. 245 divided by 100. And worked your way back until you got a whole number. So this is the square root of 49 times the square root of 5. What is the square root of 49? 7 square root of 5.
How are we gonna know, like, you said there's an extra step.
Okay.
How are we gonna know the difference? Like, it's really on test. How are we gonna know the difference between like 3 and 8?
Because 144 was already a perfect square, 72 was not. So you had to recognize that. Yep. All right, so this is the same thing as having 5 times the square root of 72. That seems pretty, the 5's out front, that's multiplying. The problem is 72 is not a perfect square, so I'm not going to get a whole number. So what I have to do is I have to treat the 72 like I've done these previous 4. I'm not going to do anything with the 5 just yet. So I'm just going to bring it down. I need to split up the 72 to find the largest perfect square that goes into it. So I would start probably with 64. 72 divided by 64. No. 72 divided by 49. No.
It's already got that rate.
72 divided by 36. There it is. 36 times 2 is 72. Then in my next step, I just broke apart the 36 and the 2. So it's 5 times the square root of 36 times the square root of 2.
We're putting the calculator like that.
Nope. What is the square root of 36? 6. So this is really 5 times 6 times the square root of 2. What is 5 times 6? 30. So your final answer is 30 square root of 2.
Yeah, thanks a lot, Shante.
It's a lot of work.
So really, without the 5, it's what you were doing. You just ended up multiplying that outside number by 5 at the end. That was just the extra step. So try number 9. All right, so this is 3 times the square root of 45. 45 is not a perfect square, so I need to know what perfect square goes into 45. 9. 9 times what? 5. 9 times 5 is 45. So far, I'm just rewriting things. So this is really 3 times the square root of 9 times the square root of 5. What is the square root of 9? 3. So this is really 3 times 3 times the square root of 5. And what is 3 times 3? 9. 9 square root of 5. These notes we're going to stop here and do some practice on this.